Hello everyone, today in this video we will be discussing the module 3 of system software. So in module 3 what all we have is the totally how many topics are there? 5 topics. Okay, 5 topics are there in total. Fine, so there is less theory, like only 10% is theory and 90% is numericals. Okay, numericals are the problems. Also it's included with algorithms. So how many topics are there? 5 topics are there. So what are those 5 topics? The first topic is introduction. In introduction we have some theoretical concepts like role of the parser, representative grammar, syntax error handling and error recovery strategies. The questions which can be asked here is what is the role of parser and what are the different error recovery strategies. Those are the important questions. Okay, and context free grammar, what is a context free grammar, those questions can be asked. And the main thing you have to focus here is the parse tree derivations, LMD, RMD and ambiguity. These 3 things you have to focus here, and rest of the theory things that you need not focus much upon because those are not asked much in exam. Okay, so this is the second topic, context free grammar. The first one was what? Introduction. Here we had the role of the parser and the error recovery strategy. There are 4 strategies here which we will be studying, and then we have the context free grammar. Here is the theoretical things, and then we have the main thing which is parse tree derivations and ambiguity. Then we have writing a grammar. Here we have the main thing which is eliminating ambiguity. Okay, eliminating what? Ambiguity by using 2 things, left recursion first, then left factoring. After we have done both of these, then we are supposed to do the first and follow, then LL1 grammars. Okay, so this question can come 8 to 10 marks. Find the LL1 grammar. I'll show you the question how it looks like. You can be asked with this question, find LL1 of the given grammar, and first what you have to do is first you have to find out the left recursion, and then you have to do the left factoring, and after that you have to do the first and follow, and then you will be doing the LL1 of grammar. And this one algorithm and the specific question can be asked, and you have to write the specific algorithm for that, and those are the important questions here. In bottom of parsing, there is just one problem here, shift reduce parsing. Okay, and handle pruning is and reductions and conflict during the shift reduce parsing are the theoretical concepts. So what all you need to focus upon, just let's just quickly go through it. The role of the parser and error recovery strategy, the first strategy is 2 questions, and third question is the parse tree and derivations and ambiguity. And after that we have the elimination of left recursion, left factoring, and first and follow, and LL1 of grammar, that is the 5th question. And then we have the recursive descent parsing, the specific question you have to try the specific algorithm, that's the 6th question. And then we have the shift reduce parsing. Okay, 6th question, I mean 7th question, and these are the theoretical concepts. Okay, so these are the 7 and 8 questions which you have to focus more upon. 7 to 8 questions are there which is in module 3. Okay, so how will be the flow of the paper, but question paper. Before that, let's see what are the previous questions. Here by topic wise I will be explaining what are the questions that can be asked from the first topic. Okay, what first topic you have how many questions? 2 questions. Role of the person, error recovery strategies. As you can see here, write a role of the parser. What is the role of the parser, and explain the different error recovery strategies. That's the first thing you can expect. That's the thing which you can expect from the first chapter, which is introduction. Then what we have the next one, which is context free grammar. Here we have the parser and the derivations and ambiguity. So what question you can be asked is the numerical type. Okay, so I'll show you how the question can be asked. So this is the given grammar, and this is the input string. You have to find the LMD, RMD. We have to draw the parse tree and see if the grammar is ambiguous or not. Grammar is ambiguous when you have 2 or more LMDs or RMDs for the same thing, or you have the different LMDs or RMDs for the same input. Okay, by both of these methods you can say that the grammar is ambiguous. And then we have the describe the language generated by grammar and the left factoring of the grammar. So these can be asked under the topic context free grammars. Okay, this is the most important topic which you need to focus upon. Just the numerical values can be changed, but that problem type is same. Okay, then we have the left recursion, left factoring, and then we have the first and follow, and then we have the LL of 1. Okay, so these are the things which you need to focus upon. So what are the questions that can be asked in those topics are define left recursion, eliminate the left recursion from the following grammar. This is about the left recursion. And see, all of these questions which are I am showing here is not the part of syllabus, because it's from the previous year schemes also. And what I'll be just discussing, you just note it down so that you can get to know what you have to focus upon. Okay, and okay, first and follow is here, and predictive parsing, which is nothing but LL of 1. Also left factoring is there. I guess I have not mentioned here. No issues, I will be mentioning while I will be solving the problem. You'll be getting to know how to solve the left factoring as well. So let's get started with the topics. Yeah, here I got the left factoring question. It can be asked in this way. I also shift reduce parsing is there, and recursive descent parsing. Don't worry, I will be telling you what is the flow. See here, this is the first topic, which is the role of the parser. And before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, And here we have the first topic, which is role of the parser. So what is a parser? Parser does the parsing thing. Okay, means once it has got the tokens, it will join the tokens to form a meaningful sequence. That is the role of the parser. Okay, so here we have the source program in which the lexical analyzer will do the things. Means the source program is here. Lexical analyzer will divide the program into tokens, and those tokens will be sent to the parser. Again, what happens? Here's the source program, and lexical analysis will happen, which means it will divide the program into different tokens, and that tokens will be passed to the parser, and parser will make a parse tree out of it. Okay, means the grammar rules it will apply and form a parse tree like this. Okay, it will form a what? Parse tree. Then that parse tree will be passed here, and that will be the intermediate representation. For both of these three things, you will be using the symbol table in between. Okay, so that's the main role of the parser. From lexical analysis to parser, and parser will join the tokens, form a meaningful sequence. Okay, that's the parse tree. Next to this, we have the topic which is the error handling and recovery strategies. So what are the different types of error which can occur? Lexical errors, which includes misspelling; syntactic error, which includes the misplaced semicolons; semantic errors, which is a type mismatch; and the logical errors, which can be any part of the program, like double equal to or equal to, you are interchangeably using, that is the logical errors. Okay, so how to handle those errors is, the best way to handle the errors is these three things should be there: report the presence of errors and recover from each error, and add minimal overhead to correct the program. Okay, so these are the three things which we'll be keeping in mind when choosing which error strategy we need to choose. Okay, so panic recovery mode also, how many recovery strategies are there? Panic recovery mode, phrase level recovery, error productions, and global correction. Yeah, 4 are there, so let's discuss each one by one. Panic mode recovery, what it will do, it will with this method, on discovering an error, the parser discards the input symbols at a time until the valid symbol is formed. Like for example, if I have read intin I have written. Okay, so it will discard this and see int has a meaning. No, it doesn't have a meaning. It will cut e also and check if int has a meaning. It has, and it will accept that one. Phrase level recovery means, on discovering each error, parser may perform local correction on remaining input. That is, it may replace a prefix of the remaining input by some string that allows the parser to continue. So here's a string, it will replace the prefix of it with some valid values, so that it becomes the whole valid value. That is the phrase level recovery. Error productions means, if there is an error here, that error's production should be defined, so that whenever this this is encountered, at that time the error will be means reducted. Okay, and finally we have the global correction. Here we would be implementing some algorithms that would be least cost correction, because always we need the least cost and the best efficiency algorithms and all, right? So global correction, what it will do, it will choose those algorithms which will be least cost error solving algorithms. Okay, so this what is the important, the first chapter that we are focused upon from exam point of view. Let's move on to the next 4 chapters, which is having these topics. Okay, so I will be solving each numerical means numerical from each topic. Let's get go through it. What are the topics? Parse trees, you need to know how to means draw. What is LMD, RMD, how to draw that? What is ambiguity, how do you find define ambiguity, and how do you find out if it's ambiguous, and what you need to do if it's ambiguous? Those are the type of the question which you can expect in exam. Okay, left recursion and indirect recursion, it's one and the same, just slightly difference is there here. And left factoring is there, it's the next step after left recursion. Then eliminating ambiguity, what you have to do to eliminate ambiguity, that's the next topic. After that, you need to know the top down parser. In that we have the recursive decision parser, this is the algorithm, and for the specific problem input they give, you have to write the specific algorithm for it. Then we have LL of 1, in which the first and follow is included. So you need to learn what is first and follow, then you will be able to do LL of 1. Finally, we have the shift reduce parser. This is also just a theoretical not theoretical, problem concept. You need to know the steps, and you will be easily able to solve in exam. Okay, means if they ask. Then we have the handle pruning, which is theoretical concept, and that will be seeing in the upcoming topics. So let's get started with the first topic, which is how to draw the parse trees, LMD and RMD, and ambiguity. Okay, so this is the first topic, which is parse trees, LMD, and ambiguity. So this is the first type of question which you can expect in exam. This is the grammar given to us: S goes to SS plus SS star or A, and this is the input which is given to us, which we have to perform the operation upon: A plus A star. Now the first question is give the LMD for the string, then the question is give the RMD for the string, then give the parse tree for the string, and then is the grammar ambiguous or not, justify. Okay, so let's start from here. Give the LMD for the string. So what is the string given to us? A plus A star. So to give the LMD, it should end with this one, right? You have to observe carefully what it is ending with. Okay, it is ending with star, so we'll be choosing this one. So first we will be writing here S. Okay, S goes to SS star. Okay, this is about the LMD. S goes to SS star. Now in the place of S, what I can say, I have to start from the left, right? So I'll be starting from here. So in this place of s, what I can substitute? See here, as you can see, it is a plus. So in the place of this, I have to substitute ss plus, right? So what I will be doing is ss plus, then this s and star will be as such. And it should start from here, substituting the values, right? So what I will do is I'll be substituting the value as a initially here, as plus and s star. Then I will be doing the same thing, continue a plus s star, then a plus a star, and that's the final answer. This is how we perform the LMD. And let's discuss how to perform the RMD operation. In RMD, what you will be doing is you'll be writing the same thing. It's ending with this one, so I'll be obviously choosing this one only. So I'll be writing here s goes to ss star. Then what I will be doing is ss star, it's ending with right. I should start from right, so I'll substitute this one as a because the next letter is a here. So I'll write it as a, and this will be s only. Then the next letter I have plus aa. So for that I need to use this one, right? In the place of s, I will be writing ss plus. So in the place of this, I will be writing ss plus, then a, and here star is there. Then from the right, I will keep on substituting sa plus a star, and then finally I will be writing aa plus a star. Okay, so that's how we perform the LMD and RMD. So to generate a parse tree for it, what we'll be doing is we'll be writing here s, and for this one, what is the parse tree? See here, for the s, what I did first, s and then star. So this s was substituted as a after in the later stage, but here I had done as ss plus, and this s was written as a. Here also it is a, and here it was a. So this is the parse tree for this one, and here also I'll be doing the same thing, just the order is different. Here I'll be having star ss, and this was substituted as a first. Then what I did here, I wrote this as s and plus, and this was written as a, this was also written as a. As you can see, the LMD and RMD both are same. So this is LMD and this is RMD, both are same. So if both are same, what does that mean? It's unambiguous. Okay, if both are same, it means unambiguous. Okay, so that's the justification which we will give for the grammar. Okay, so this LMD is unambiguous. So that's the first type of question which you can expect in the exam, the parse trees, LMD and ambiguity. Okay, so let's move on to the second topic, which is regarding the left recursion, then followed by left factoring, and then we have the eliminating ambiguity, and then follow up topics like first and follow, LL of 1 grammars. Okay, so let's do that. Let's move on to the second topic, which is the left recursion. So we need to know what is left recursion and how to eliminate it. Okay, so what is left recursion is, if I give you an example, and that time you will understand what is left recursion. E goes to E plus T is given, right? E goes to E plus T. So here, as you can see, E is starting letter, and here also E is starting letter, or T, here it is different letter. But what is starting letter, that is known as left recursion. Here the recursion is happening, right? So you have to remove this left recursion. So how do you remove the left recursion is, you have to remember this formula. So see here, A goes to A alpha 1. This is the form which is given to us. A goes to A alpha 1, A alpha 2, A alpha 3, and here beta. Okay, so here what is the A value? A value is the same letter what is present here. So here instead of E, the value will be taken as A. So this is considered as A, this is also considered as A. Okay, and the remaining one, what is with A, which is not common with this one, that is known as alpha 1. So here the alpha 1 is nothing but, so here since only alpha is there, so only one alpha is there, we can take it as alpha instead of alpha 1. Here it is plus T, so plus T will be taken as alpha. Okay, and the remaining one which is alone, that is taken as beta. Okay, which is not with A, that is taken as beta. Now what we are supposed to do is we have to write it in this form. So in this form, as you can see here, it's written A goes to beta alpha dash. Okay, so here instead of here we have to write it in this form, A goes to beta alpha dash. Okay, so what is the value of A? We have taken A, we have taken as E, right? So here in the answer part, what we will write is E goes to, what is beta? Instead of beta we have here as T, so we will write it as T, and alpha dash means instead of E we will write as E dash. Okay, that's the first thing what you have to do. And after that you need to come here at that point, at this part what you have to write is A dash is equal to, so you will write E dash is equal to alpha 1 A dash. What is alpha 1? Plus T, so you will write plus T, and alpha dash is E dash. So since we don't have alpha 2, we will keep it, we will not do anything to that, and last we will write as epsilon, so or epsilon. So this is the thing, if you remember this one, you can easily solve this part. Okay, so let's solve another similar question here. So T goes to T star F and F here. So as you can see here, T goes to T star F, right? So T is taken as A, and star F is taken as alpha, and F is taken as beta. So what's the first step what you have to do? So first step what you have to do is you have to write T goes to, and what is the beta value? F and T dash. Then T dash goes to, what is alpha value? Star F, again T dash or epsilon. This is how you solve the left factoring, left recursion. The next one is left factoring. Left factoring is pretty simple one. It's very easy. What you can do is directly you can do, see here, S goes to SS plus SS star and A. What you can find common here? the common thing what I can find here is SS, right? So what I will do is S goes to SS, and here I'll take as S dash and or A, and instead of S dash I'll be having two possibilities, either star or plus. So I'll be writing here S dash goes to plus or star. Okay, same thing goes here here as well, because here we have IETS and here also we have IETS and here it is A. So the answer will be as follows: S goes to IETS, S dash or A, and S dash goes to this one. Here epsilon is there, so we'll take as epsilon, and here what we'll take, here it is ES, so here we'll take as ES or ES, and finally we'll have E goes to B. So this is how you solve the left factoring. We'll be using both left recursion and left factoring in the upcoming problem, which is of LL1. Before that, we need to know how to solve the first and follow. So let's solve one question regarding that. So this is the fifth topic, which is recursive descent on the parsing grammar. This is the grammar given to us. You have to apply the recursive descent. Okay, so the first thing what you have to do is you have to start from here, and whatever your letter you find out here, write it as function. Okay, like procedure E. After I've written that, then what all you can find is T and E dash, right? For both you have to write functions T, and instead of E dash you will write E prime for both functions. Now two new functions came, you have to define both of these. Again you will write procedure T, and in T what you can find is F and T prime, right? So you will be writing there F and T prime. Same thing goes for this also. You will be defining F, and F what we have is E means opening bracket, E and closing bracket, then ID. So here we'll have if it is an opening bracket, then continue, advance means move to the next part, then call this one E function because E is present there, and if it's a closing bracket, then return true means it's a valid string, else return false. Okay, then for ID we will not be doing anything, we will be just keeping it as such, and then what we have is the E prime and T prime. So both of these we have to define the same way. We will define if okay, so ID is here at last, we have to write for ID as well. So for ID, if you write here, if input is equal to ID, return true, else return false. Okay, then you have the procedure for E prime. The for E prime also will be doing the same thing, star, advance, T, E prime, and then return true. Okay, for T prime also will be doing the same thing, and yeah, that's all what is there for recursive descent. That's how you solve the question for recursive descent. Okay, now we'll be seeing the fourth topic, which is regarding the first follow and LL of 1. So to solve LL of 1, you need to know how to solve the left recursion as well as the left factoring. Okay, so this is the 4-step process. The first step is the left recursion, then we have the left factoring, and then we have the first and follow, and finally we have LL of 1. Okay, so let's see what are the steps involved in it. I'll be solving the question of LL of 1 so that all the things are included, and it will be a revision for you as well. So let's take up a question, sample question. So the question is as of see, this is the question. Let's write it here. Topic number 4, which is first and follow as well as LL of 1. So first and follow is a separate topic, but it's a part of LL of 1. To solve LL of 1, you need to know how to solve first and follow. Okay, so we'll be covering these both topics together. Okay, so this is the question which is given to us. S goes to SS plus SS star and A, and the input which is given to us is AA plus and A star. Okay, so this is what the input which is given to us. Okay, so let's find out. The first step what you have to do is left recursion. So let's solve the left recursion. So what is the left recursion? You can see here S goes to S, here also S. But you need to solve the left recursion. So what is the formula you need to apply? The previous topic we discussed, right? This is the formula which you need to apply. If A goes to A alpha 1, A alpha 2. So what is the alpha 1 and alpha 2 here? That we will be writing down. So S goes to SS plus SS star and A. The thing which is alone is called as beta, and the thing which is not common is known as alpha 1, and this is the SS values. What is the first step you have to do is you have to write it in this form. A goes to beta A dash. So S goes to what? Beta S dash. Beta is A, so A S dash. This much you understood. S goes to A S dash. Then what we have? A dash goes to A dash. Instead of A dash we have S dash, goes to alpha 1 S dash, alpha 2 S dash. So what are the two alphas we have taken? Just we are concerned with that. S dash goes to, what is the alpha 1 we have taken? S plus S dash or S star S dash, right? And finally we have epsilon. Okay, so these are the two rules which I have generated. Now we have to do the second thing, which is left factoring. So how do you do the left factoring? In the left factoring, what happens is you have to find out the common terms. Is S common here or anything is common here. Here what you can find common is s, you can find common, right? So we'll be writing this rule same as here. S goes to a s dash because nothing is common there. S dash goes to s is common, so take s as common, and instead of this one and this one, write as s double dash, and here epsilon is there, so I'll write epsilon. Find out s double dash. You have to define s double dash, take it as plus s dash or star s dash. So this is the second part which is done, which is left factoring. Now comes the third point, which is the new topic, first and follow. So let's see the steps involved in first and follow. You need to carefully solve these problems, first and follow, because it's a bit complicated, right? So what you have to first step, what you have to do is you have to note down the non-terminals here. What are the non-terminals that you will be noting down here? So how many equations we have? This equation 1, equation 2, equation 3. Just copy paste it here. So s goes to a s dash, s dash goes to s double dash or epsilon, and s double dash goes to plus s dash or star s dash. And here what we'll be having is, we'll be writing a column first and we'll be writing a column follow. And what you have to do is, first you will be starting from here on the bottom. First means what? The first letter. So first letter here and first letter here, that will be noting down here, plus and star. First letter here and first letter here, that will be noting down. But wait, here the first letter is a non-terminal. Okay, first here letter is a non-terminal, so we'll stop it, don't do anything. If it is a non-terminal, what you have to do, I'll tell later. First the go to here, this is s, right? So s is also not defined first. So if you can define s first, that you do. Whatever you can do first, do that. Okay, means terminal is here, do that first. Here it is a non-terminal, we'll look later. This is a terminal, this is the first letter, so write it as a. After you have done this much, come back to those which you haven't done. You haven't done this one, right? So you'll take up this one, and what you have to do is, since it's a non-terminal here, the first letter is what? A non-terminal. If it's a non-terminal, what you have to do is, you have to go to the this part, s is there, s parts first. Go to the s parts first and write that here. Means s parts first is a, so you'll be writing here a. Next one is here is epsilon, you'll be writing as epsilon. Understood, right? How we did? You'll be going to the s part here, and then you will be finding out what was in s first, and that you will be copy pasting down. That's how you solve the first. Then you will be solving the follow. For the follow, you have to start from the start symbol and write it as dollar first. Okay, every time there will be a dollar here. After writing the dollar, what you will be doing is, s is there, right? You will be searching s in this part. Wherever you can find s, just underline it. Here I can find s. So if you found s here, what's your next step is follow. You are doing for follow, right? What does s follow? S follows s double dash. S follows what? S double dash. So if it follows a terminal, you will be writing here as follows. If it was like closing bracket here, instead of this one, if it was closing bracket, you will just write closing bracket. But since it's not a closing bracket, what you have to do is, you have to go to s double dash. After that, after you go to s double dash, copy down its first. Copy down its first. I'll repeat. Here you are present. The next one is a non-terminal. So go to non-terminal and find out the first of it, and that you have to write here, plus n star. Okay. Let's move on to the next one. S dash. S dash, where you can find? I can find s dash here and s dash here and s dash here. 3 places I can find s dash. So what I will do, I'll start from here. S dash is present here. Then what is the follow of it? Follow of it is an empty space. So if it is an empty space, go back to this one and copy paste this follow. You are following it, right? So copy paste this follow. What is this follow? This follow is this one. Just copy paste it here. Dollar plus and star. After that, come back here. Here what you can find is s dash, and follow is s double dash, and s double dash, what you have to consider is, since s double dash is there, s double dash follow. S double dash follow is not yet defined, so keep it as such. Here also you will come and find you have not defined it, keep it as such. Okay, we will do it later. So don't close it, keep it like this only. Then come to s double dash. Okay, means this is done, and you coming to s double dash. Where you can find s double dash? You can find it here. So what follows s double dash? S double dash follows nothing, right? Again it follows s dash. So what you have to write is, if it follows s dash, you have to write the follow of s dash. Okay, because it's following s dash. Here also we did the same thing. Follow of s we wrote, copy pasted. Here follow of s dash, that will copy paste here. So here we will have dollar plus and star. Okay, so since these both are same, we'll just close it. Now there is a scenario that what happens is you will get the first of it. For example, if there was a situation like after s it was s dash, after s it was s dash. Okay, so what you will do for this one, you will find s is here, after that s it is s dash, so you will come to s dash, s dash first is this one, and here you will find a is there. So what you will write, a you will write, after that epsilon is also there, but you cannot write epsilon in follow. Instead what you will do is, epsilon is there, right? So for s dash what you will do, you will substitute this as epsilon. If this is epsilon, then the last letter is this one. This one means s is there, s will again come here, and s dash will come. So follow of s dash you have to write. So the same thing which you are trying to find out, that same thing if you have to write, you can skip it. Okay, because that's the recursive one. Okay, so that's how you solve the first and follow. Now after you have means got this these two things, then you have to do the first step, which is the parse table. This is the step for ll of 1. Parse ll of 1 table. Now how do you do the parse ll of 1 table is pretty simple. What are the non-terminals you can find in this whole thing? Non-terminals you can find is s here, so we'll write s dash is here, s double dash is here. That are the three non-terminals, right? After that, write down what are the terminals you can find out here. The terminals which you can find out is a, plus, star, and dollar. These are the terminals which you can find out. Okay, now we have to see this one. Now you have to see this table. Okay, in this table what you can find is, first is a here, so s and a, where you got from this one, s goes to s dash, right? S goes to a s dash, that you will write below a, because a is present here, that you will write here. Next, again go to the next one, s dash. How did you get a I got because of this one, right? Because of this one only I got a, right? So below a I should write s dash goes to s double dash. This I'll write below a, and after that we have epsilon. If epsilon is there, go to follow, and here in these three places below that write epsilon value, means s dash goes to epsilon, s dash goes to epsilon, s dash goes to epsilon, s dash goes to epsilon. Okay, again I'll repeat what I did. Here I had two things, a and epsilon. A how I got by this one, so I wrote this equation below a, and epsilon how I got, epsilon if you get means if you encounter epsilon here, go to follow, and in the under the follow of these three things, right, s dash goes to epsilon, s dash goes to epsilon, s dash goes to epsilon, s dash goes to epsilon. Then finally s double dash is here, so s double dash, again do the same thing. Where you got plus from, write that one below the plus sign. S double dash goes to plus s dash. Star where you got from, the star we got from the this one below star, we will be writing s dash, s double dash goes to star s dash. This is the thing which you need to obtain in the end. Now observe here carefully if the grammar is ambiguous or not. If the grammar was ambiguous, what will happen is two or more things will come here. Two or more things will come in the same block. That is known as ambiguous. But here it didn't come, nothing repeated in the same block, so it is unambiguous. One last step what we have to do is the stack operation. So stack operation we need to refer this table. Okay, so take a screenshot or write this table somewhere. I'll be referring this table in the next page. Okay, I'll not be turning the page. I've written the table in another paper, so I'll be seeing that and writing. Okay, so here first step what you have to do is you have to write it as stack input action. This is the last step. Okay, so here what you'll be starting is, you'll be starting from s, because they have given to parse for the particular input, right? In the question they have given to parse for the particular input, so for this input you will be parsing. Okay, so here the input which is given to us is a plus a star. After that I add dollar. Okay, after you have written this one, what you have to do is you have to observe this one, s and a. Where does s and a goes to? I will show you for one. S and a, where does s and a goes to? S and I mean here s and a, where does this goes to? S goes to a s dash. So instead of s I will write a s dash. S a was there, so I will write s goes to a s dash. I will just write a s dash in the place of s. So in the place of s what I will write is a s dash, then again dollar, then here a same I will copy paste, and what I just did is push s goes to a s dash. That's what the step I did, right? So again here first letter it's same. If it's same, just cut them both from both the sides, so it will be means the remaining thing will be this, and right here matched a. Okay, then again do S dash goes to A. What does S dash goes to A is? Check the previous table here. S dash goes to A. What is that? S dash goes to S double dash. S is double dash. So instead of S dash, I'll write S is double dash. Okay, like this. Then this I'll be copying the same thing, and here I'll mention S dash goes to S is double dash. Same thing I'll do here. S goes to A. What S goes to A? S goes to AS dash. So in this place I'll write AS dash. Then dollar, and this I'll be copy pasting the same thing here. And here what I have pushed S goes to AS dash. Okay, then again I'll be doing the same thing here, match. So just remove it and write here as matched A. Then S dash and plus. Where does S dash and plus goes to? So S dash and plus goes to epsilon. So if it goes to epsilon, instead of this place I'll write as epsilon. Epsilon means I can just remove it and I'll write S double dash here, and here plus was there, it will remain as such, and here it is this one. So push S dash goes to epsilon, that I'll write here. S double dash and plus. Where does S double dash and plus goes to? S double dash and plus, it goes to plus S dash. So I'll write here plus S dash and dollar and plus A star dollar. What it just did, push S double dash goes to AS dash. Is it AS dash plus S dash? Okay, it was plus S dash, right? So here I'll be writing plus S dash. Okay, S dash double dash goes to plus S dash. Next step, here is the same thing, so just remove it. S dash dollar A star dollar, and here what we have is matched plus. Then S dash and A. Where does S dash and A goes to? Here already we have done. S dash and A goes to S is double dash, right? So I'll write S is double dash and dollar here, and A star dollar, push S dash goes to S is double dash. Then what we have is S and A. So where does S and A goes to? AS dash S double dash and dollar. Here we have A star dollar, and here we have push S goes to AS dash. A and A, it gets cut, so S dash S double dash and dollar, star and dollar, and here we have matched A. Then S dash and star. Where does S dash and star goes to? S dash and star, if you observe carefully, S dash and star goes to epsilon, so I'll just ignore it. So S double dash is present here, star is here, and push S dash goes to epsilon. Okay, S double dash and star, where does it goes to? S double dash and star, S double dash and star goes to star S dash. All right, star S dash and dollar here, and here's also dollar, and this one I just pushed S double dash goes to star S dash. This one what I pushed. Now what you have is the same thing, so we'll match it. So here it will get vanished. So I'll just write match star. Then we have S dash and dollar. So where does S dash and dollar lead us to? S dash and dollar leads us to epsilon. So what I'll write is just epsilon. I'll just remove it, and here also nothing is there, and I'll just type as accept, because nothing is there in both sides. It means it's accepted, and the grammar is unambiguous, and the string is in LL of 1 parsing. That's the last sentence which you have to write. In case if it was ambiguous, what will happen is at a particular instant of time, like for example here I have S dash goes to star. So what I will have is in S dash goes to star, here I'll have two or more things, so I'll not be sure of which to substitute. So what you will do, you'll just stop there and you'll write here there is an ambiguity of substituting two things, and therefore the grammar is unambiguous and not in LL of 1. Okay. So this is the last topic of this module, which is the shift reduced parsing, and this is the topic number I guess 7. Okay, so what is shift reduced parsing, that we will be discussing. So there will be two things happening, shift and reduce. Okay, so the question can be as follows. Let's take an example question. L or A, L goes to L or S, and S. The input which is given to us is a comma a and closing bracket, and here we have the stack, and here we have the input, and here we have the action. Okay, so in the stack we'll be starting from dollar, and in the input we'll be writing the same input present here, a comma a, and in action we'll not write anything initially. Then what you have to do is you have to shift this thing here, means any of the operation is defined for this one, no, right? First thing you have to shift here, then only the thing will start. We'll shift it here and we'll write it as shift opening bracket. After that actually you have to write this here, shift opening bracket, and after that since a is present here you will be shifting a as well, so this one we can make it as a opening bracket a comma a, and here what we will be doing, we will be seeing, okay, see here a is present here. Okay, so for a what we can do is a is present here, a can be reduced to s, right? So for this I will write as reduce s to a, so a will be reduced as s, it will be written as opening bracket s, and here will be the same things. And here what we will be doing is, since s is present here, can s be reduced to something else? Yes, it can be reduced to l, so we will be writing here l comma a, and here I will be writing reduce l goes to s, so it is reduced to l as well. Okay, so next what we will be doing is, l is present here, can l be reduced to something? No, so we will be shifting this here, so we will be writing shift comma, so when we will shift comma it will be l comma, and this will be a comma a, and after that l comma is there, can we do anything? No, we can't, so again shift opening bracket, so we will be getting here as opening bracket a comma a. Can this be done anything, any operation is defined here? No, so we'll be shifting a again. After I've shifted a, the stack content will look like this, and then the a will be vanished from here. What we can do is you can convert this a into s, then s into l, right? So we can reduce s to a first, so it will be written as s, here it will be the same thing, and again reduce to l, reduce l to s. Okay, so it will be reduced to l comma l, then again this will be shifting here, so for now just keep it as such, then you will be writing shift comma, so we are shifting comma, so l comma and a will be written here. Can anything be done here? No, it cannot, so again shift a, so when I will be shifting a here, I will get as this, and a will come here, and then two closing braces are here because a is shifted here, then we will be reducing s to a, so it will be as follows, l comma s, right, and here I will have this one and this one. So if you observe carefully, what we can do now is l comma s can be converted back to l comma s can be converted back to l, so what I will do is reduce l comma s, means l goes to l comma s, so this whole thing I can write as l, right? So l comma l, then after this thing will be there, I can shift this thing, shift a closing bracket, so here I have l comma l and closing bracket here is just one bracket is present here, here I have this one. Now this can be reduced, right? This can be reduced to s, and then further s can be reduced to l, that's what I'm going to do, reduce s goes to l, so here instead of this I will be writing as s, so here I'll have opening bracket and l comma s, and here I will be having this this one here, and l comma s can be converted back to what? L, right? L comma s can be converted back to l, that's what I'm going to do, reduce l comma s to, means l goes to l comma s. If I do this one, this will be converted back to l, so I'll be writing here as l, and this will be as such, and I'll be shifting shift closing bracket, so if I shift closing bracket it will be in this way, so here it will be just dollar, because all the place I had to add dollar I didn't add, but you do that in your exam paper. And here what we will be doing is reduce s goes to l. Now if I do this one, it will be replaced with s, and when you get here as s finally, that's the starting symbol here, then what you will be writing is accepted. This is how you do the shift reduce parser. Okay.